Hey YouTube, what's going on? Quadratic functions and revision right now. That's about the problem solving. So some problems you need to set up quadratic equations. Maybe first it will be fractional one, so definitely not linear. And in this way you need to resolve common to quadratic functions or quadratic equations. So that's all about that. And we've got plenty lots of stuff where to go through, but the main strategy here is that each problem statement, so you have several statements in the problem, and each problem statement you need to convert into algebraic form so that finally will form some quadratic equation. Okay, so that equations can be resolved using the main approaches how we actually resolve quadratic equations. There might be factorizing, there might be usage of quadratic formula. If you are not confident and probably don't know the ways how we can resolve quadratic equations, just please watch my series with the best explanation about how to solve quadratic equations, either through factorizing or applying quadratic formula. So I never advise you to use completed square because it's really like difficult in application methods. So, and actually mathematicians are not using that. So that's why make sure you understand how to factorize easily and how to use quadratic formula. All right. So if you're ready, guys, I'm going to start. First of all, I just show you the blocks that we need to go through. So that's the first task. Try to pause the video, try to make screenshots in order to go by your rounds, okay? And only then try to compare it with my solutions. So in most cases, you'll be given triangles for the first like 3 tasks, some rectangle area, and here are sort of word problems. So the first block, so problem number 6, that's about projectile. Hope you remember how to apply that. If not, just have a reference to physics that it gives you good explanation what projectile is. Okay, and the last 2. Okay, so if you have a print screen of everything, so it seems to me that it's reasonable to split in 2 parts. So we'll take in the first block and then go to the second in the next video. So here we are going to cover 3-4 problems. Okay, let's get started. So the first one, on the rectangular field, there are 2 shaded regions, so marked as green shading and blue, dark blue shadings. All right, so they have equal areas. That's the key statement here. So equal areas. So make sure you remember how to calculate area of triangle, which is half of the height times the base. If you're not sure where it comes from rectangle with sides A and B, or let's put the side H instead. Okay, and you split this rectangle on 2 equal parts so that it will form right angle triangle. So as you can see, the area of triangle is half of the total area of rectangle, which is H times B, and then you have it in order to get the formula for the triangle. All right, so I hope that you understand that. And we need to find the unknown length. So unknown length is here, that small one. So I put the red in order to mark it as unknown length. So this is simply, let's say, the base of this greenish triangle. Okay, so let's get started. So area of the green one, so put the green. So area of the green triangle, how to work it. So you have 7 times x over 2, height times the base in over 2. So this area actually equal to the area of the small tiny blue one, okay? That small tiny blue one. This also in triangle. So let's see what they have. It has two equal sides, so this small triangle is an isosceles, so that makes calculation more easily. So let's set up some unknown values for the side. But okay, you can mark as, y, for example, as unknown, but let's have a look at the segments. So in order to do this very fast, don't input like really lots of variables. So let's have a look. So we actually wondering about the side lengths. So the side length here, and that's equal to that side. So we're actually looking for two legs because it's isosceles triangle. So how to find this part? We know that the whole length is 1 meter, so it's here, 1 meter, right? So we have the part of the segment, which is x, so the rest part obviously is 1, the whole segment length, minus x. So that's why each side is 1 minus, I put it here, so and say that this part is actually 1 meter minus x, so meters. And that's equal to that side, so we can figure out that it's going to be x minus 1 squared. Yeah, we're multiplying two identical legs and we divide by 2. Because area is the same, we can equate area of the green to the area of the dark blue, okay? So that's how it works. We actually converted each statement into algebraic form, and then we put it in equality because we have two sides equal. So actually we've got 7x over 2 equals x minus 1 squared over 2, which is quadratic equation. So we can times by 2, so we can simplify that. And now this is the basis or the basic equation for us. So we're left with 7x equals, so x minus 1 squared, we expanded x squared minus 2x plus 1. So make sure you remember how the quadratic formula works. If not, just simply multiply x minus 1 by itself and expand the brackets. Okay, I'll use the shortcut using the square of the difference, sort of quadratic, not the quadratic formula, I mean in sense of quadratic equation, but you know what I mean. Just simply I use x minus y squared, the formula which is x squared minus 2xy and plus y squared. So I use that. Okay, so next we transfer 7x here, and we've got to the right side, and we've got x squared minus 7x and minus 2x minus 9x and plus 1. All right, so we've got 0 from there, and we need to solve. I'll solve using quadratic formula because I can see that I'm thinking one step ahead. I calculate discriminant, which is b squared minus 4ac. In our case, it will give you a not so good number, because if you evaluate discriminant, it's 81 minus 4, right? Which is 77, and it's not good number because square root of discriminant doesn't it's not whole number, it's a rational number, it's third. All right, so that's why the general form of that is 9 plus minus square root of 77 and over 2. So that's in meters, that's answer in meters, so make sure you have the same. We're actually working with thirds here. So if you want to calculate precisely, so exact values to, let's say, 2 decimal places, so we actually need to calculate. So first of all, we understand that square root of 77 is less than 9, right? We can estimate without a calculator, so square root of 77 is less than square root of 81, which is 9. So we make sure that we can check that 9 minus square root of 77 is positive, because by definition the side is not going to be negative. So that's why we have two options for value for x. So we might have several x values. All right, so let's take the calculator and just calculate. First, I add 9 and square root of 77, and the result I'm going to divide by 2. Okay, so what I've got the first value for x is about 13.39 meters. Let's calculate with difference. So if we change the sign for difference, we've got x to 4.61. So 4.61, and their exact values to two decimal places. Okay, so it's done. So make sure you did in the same manner, and we'll go next. Okay, so what we have, let me see, we have the big triangle, which is right angle, so both triangles, and the small one is also right angle. Okay, so first of all, that's the problem about similar triangles. So you need to find a value of x, and you see that each side here, so for example, you take an IH, is x minus 0.5 meters, that side. That side, HK, is 3x minus 1 over 2, here. And that side, I, comma, H, is x over 2. So, how to resolve this sort of problem? So, the figure drawn up to scale means this is not, H is not a midpoint of the two. So, it doesn't split the segment I, comma, K into equal parts. So, what to do in this case? Actually, you need to consider two similar triangles. So let's say IKH, the small one, so we have similar triangles, and triangle IKH is similar to the triangle, the big one, I, comma, IK. So why? Why is the reason for that? So first of all, I'm going to use two sides, so one side and two equal angles. So actually, if you prove that all two angles the same, right? So for example, 90 degrees and some other angle, if they are the same in two triangles, the third angle automatically be equal. All right, so how to work it out? Simply 90 degrees here, and that's in the big triangle, and in a small triangle we have also 90 degrees. So you can say that in the triangle IKH, small one, angle IHK, so H is the vertex of this angle, so angle that is 90 degrees, and it equals to the angle in the big triangle, so actually angle I, which is also 90 degrees. What about the second angle? The second angle is angle K. So angle K in the small triangle is equal, we don't know the value, but we know that it actually the same angle as in the big triangle is also K for triangle I, comma, IK. So we know two angles, and this angle automatically will be equal to that angle. So I mark the angles, let's say alpha, and this angle, let's say theta, will be equal to that angle. So how to actually understand that which angle corresponds to which? So you actually see that alpha is the common angle, so the correspondence of the sides will be obvious. But actually, for those students who are not so confident, they need to rotate your big triangle in order to have nested triangle. Just remember about trigonometry a little bit, about nested triangles when we apply trigonometric ratios for tangents. That's the same. So that's why, for this reason, I put triangle first, IHK here. So I put as it is. So let's say K is here. Okay, so that's our triangle. And now what I'm going to do with the big one in order to have the same angle here. Obviously, angle K is going to be here. So I just simply prolong the bottom side like that. And I also prolong the side IK here. Okay. And now what I'm going to do, I'm going to make them nested. So this is the case. So that two sides, IH, and the other side will be parallel. I put the arrows in order to indicate those two sides are parallel. Now we have nested triangles. But now let's mark the proper letters for the vertices of the big one. So I actually need to stay, so I vertex of the big triangle need to stay where? That's I vertex H and K for the small one. But now we need to put the vertices and label the vertices with the proper letters. So I is 90 degrees angle, so it's here, right? Both angle 90 degrees, and big triangle is also I. Okay? And I comma comes to the top, all right? So now we have this picture, and this picture allows us to see the proper similar triangles. Now you understand that which ratios you need to use or which proportion you need to use for a side, because using the fact that triangles are similar, this triangle and this, we can actually set up the proportion for sides. But before doing that, let's put the sides in terms of x that we know. HK is 3x minus 1 over 2, it's here. So next one, IH in a small triangle is x minus 0.5. X minus 0.5. Okay. So what about the big sides for in big triangle? So I comma K, so it means the longest side here in total is the sum of x over 2 and this fraction. So if you add plus here, it means that the total expression will represent the total length. So you can write that I, K is simply the addition of x over 2 and 3x minus 1 over 2. Okay, so if you simplify that, let's just simplify. So 3x over 2 and x over 2, I just simply divide by 2 every single part. We'll get 2, right? So 2x. And we're left with minus 1 over 2. Okay, so that's the value for the longest side. I'm not going to put this on picture, so I'm not going to label. Just make sure you understand. So we are going to use that. And also the last step, we need to find what? Actually, what we are going to find. We need to find this side, IK, in order to complete proportion, right? Because otherwise it's going to be impossible to figure out the values. Okay, so our final goal is to find x's. So the unknown x. So that's why we need to set up the proper proportion for that. So now we are going to do the following. So let me see. IK, yes. IK is the total length. IK is the total length. And this is here, right? This here. However, IK is also there. So what we can figure out? We can figure out using Pythagoras. So let's consider triangle IKH. So using Pythagoras, we can figure out what IK side is. So we want to figure out this side. I put the red one. So for that side, it's here. Okay. So let's figure out the size of IK. It's hypotenuse, right? So IK is simply square root of, let me see, IK is square root of x minus 1 over 2 squared. So x minus 0.5, I just write as fractions. And we actually need to add another leg, 3x minus 1 over 2 squared. Okay, so good. Next one. We've got ik as the fractions and as the third, so okay, let's simplify that. 2x minus 1, which is squared, over 2 plus 3x minus 1, which is also squared, over 2. And, 2 you need to raise to the power of 2, so I'll get 4 here and also 4 here. Because look, in the bottom part, 2 is also raised to the power of 2, which gives you 4. Okay, now we have common denominator, so I can figure out ik value as square root of the top and square root of the bottom. So I've got 2 in the bottom part. Yes, because common denominators, they are the same. And so two denominators the same, so we can figure out the top is 2x minus 1, which is squared. And here we are going to add, let me see, 3x minus 1, which is also squared. Okay, let's try to work it out now. So let's just simplify that. We've got 2 in the bottom. Here we've got, let me see, 2x minus 1. So we're using the formula. It's 4x squared minus 4x plus 1. And the rest part, which is here, is 3x minus 1 squared. So we add 9x squared minus 6x and plus 1. Seems to me this task is really long. Okay, next one, ik. So over 2, and let's simplify the top one. So it's going to be 13x squared, next one minus 10x and plus 2. That's an expression for ik. So we've got the red part ik, so we also know that ik here is going to be the same, so the length is square root of that expression over 2. So now we know all the sides and we can set up the proportion. Okay, let's go to the proportion. So let's take this red side, which is this expression, to the longest side, which is I comma k, and I comma k have the value 2x minus 1 over 2. However, we don't know x. So what we're going to do, we need to set up proportions for the sides. So the smallest side, ik, relates or in a ratio to I comma k is the same as hk, again the smallest side, to ik again. And what we can figure out from there, we've got ik if we crisscross multiply them. So crisscross multiplying will resolve proportion or ratio fractional equation, no matter how you call that. You'll get ik squared equals to I comma k times hk. Now what we're gonna do, that's the main and very significant equation that we finally got. Okay, yeah, it was a bit more complicated because actually you need to be precise when you rearrange numbers and actually variables. Okay, so ik squared is simply that expression which is squared. Let's square it up, so we just simply get rid of our square root, and we've got 13x squared minus 10x plus 2 over 2 squared, which is 4, equals to, here we need to add I comma k, which is 2x minus 1 over 2, and we add with hk. So let's say hk is 3x minus 1 over 2. Okay, so we've got almost the final one. We times 4 and just simplify that. Yeah, so let's do that. Oh man, sorry, I've got mistake while I'm adding. Actually, I need to factorize them. Sorry, multiply them. Okay, so look one more time. I, k multiplying by hk. I just look at the square and that I see, oh, what's the right side is linear, so it should be squared as well. Okay, so I multiply by 4 both parts, and actually I've got the following. So left hand side of the equation is 13x squared minus 10x plus 2, 4 was cancelled. When I'm multiplying by 4, actually I can put times 2 and times 2 everywhere for each bracket, because my goal is to cancel those 2 as well. So what I've got on the right side, so if I distribute to that terms, I'll get 4x minus 1. And in the second brackets, so if I multiply by 2, I'll left with 3x minus 1. Okay, now it works. And now let's simplify that. So we've got 13x squared minus 10x plus 2 equals 2. Let's simplify, expand. So 4x and 3x, 12x, 4x minus 1 minus 4x, then minus 3x, and minus 1 times minus 1 is plus 1. Okay, and 12x squared, of course, because 4x times 3x is 12x squared. All right, so now let's do that. Let's rearrange the equation. So we've got x squared, then we carry negative 4x to the left-hand side, and we've got negative 10x plus 4x, and plus 2 and minus 1. That's the final equation. Almost done. X squared minus 6x, so plus 2 minus 1, which is 1, so plus 1 equals 0. From where we apply the quadratic formula in order to find the final solution. Yeah, that task is a bit like boring because lots of like detailed calculations and simplifications. So let's see. For x, so minus b, so we use the formula, which is quadratic formula, b squared minus 4ac, that's discriminant, and we divide by 2a. Okay, so if we apply this formula, we'll get minus minus 6, which is 6, plus minus 36 minus 4, right? And over 2. Okay, so grab calculators and let's calculate. So I just use that and I return somewhere on top so that you can see the final answer. So the final answer here is x1 equals something, x2 equals something, because obviously we'll have two values. 36 minus 4 square root is 32. Now let's grab calculator and let's do it. So we've got 6 here, square root of 32, and we divide by 2. Okay, so first I'll use with the minus sign. So with the minus, I've got 3.17 to 2dp. Okay, so x2, I use addition on top, and I've got 8.83. So guys, as you noticed, to 2dp as well. As you noticed, we actually in two problems figure out that there are two solutions. It means that x might have two values that actually fits up to the problem that we're solving. So that's the final solution for our task. So it was based on final equation. If you didn't get the right equation one more time, just go step by step what I was doing. This is really hard task. I mean, it requires lots of passion and math and actually accuracy. So and me just sometimes when writing had a little mistake and errors or miswriting, but actually I corrected on time in time. So don't worry, it should be correct answer now. Okay, so and the main approach was using similar triangles. Okay guys, I think that there are two tasks pretty hard, and actually that's enough for this video. So make sure you've got the same. If not, just print screen and try to go step by step or rewatch the video one more time. So, and there are other problems that we need to go through. So hope it will be faster, not so maybe complicated, at least I expect. So hope you like that. So don't forget to subscribe, don't forget to share ideas, don't forget to put comments if you have specific requests about the videos you want me to create. So I understand that you guys are so different, and I trying to work out the average approach to students. But in the case you see that sometimes there might be complicated tasks that definitely for higher tier extended, and there might be like pretty simple tasks and problems that's for students who are really struggling with basics of GCSE Maths. So actually give the comments, give your ideas about the level I need to take and support during my explanation. So if you need like easy level, so no problem, but I'll differentiate. Okay, hope you like that, and up to the next episode.